Okay, so again, we're going to show you how to solve the same question, but not through long division. So I don't know if you can do it or not, but I think it's worthwhile knowing it. So what was the question? Remember, I hope I told you. The question was, I've got this polynomial, and I'm trying to divide that by this smaller polynomial. And the answer what I'll get is a smaller polynomial as well, a polynomial, okay? I should have really written what it was, but we'll be able to compare it. You'll be able to compare it to what the result we had before. In fact, I will write it down. What we had, well, we can check it later. So the way to do it is to do it like this. You'll say, okay, I'm going to have, I'll write it here. So if I divide this polynomial by this polynomial, I'm basically going to get another polynomial. Okay, hope you can see that brackets. Okay, there's nothing in that bracket. There's nothing in the bracket because I don't know what there is, but I know it's a polynomial. So what I'm going to do now, I'm going to multiply both sides of this equation by x minus 2. If I multiply both sides of these equations by x minus 2, it's simply going to go over to that side. I'm going to rewrite it. Okay, so it's going to be 5x power 4 minus 13x power 3 minus 4x squared. If you don't mind, I'm just going to ditch that 0x because it's just 0. I don't need to write it. Plus 6. This thing is equal to x minus 2, because remember we moved that to the other side, time a polynomial. Okay? And that's the polynomial that I'm trying to find out. Okay? So it's going to be that is equal to that plus that, actually plus some kind of remainder. We'll give it another color. Okay? There's going to be a remainder here. We'll write down a remainder. Just like I showed you here, if I have 53 divided by 3, it's basically 50, no, was 53 divided by 5 is 50 divided by 5 plus 3 divided by 5, okay, which is basically 10, plus a remainder 3. In other words, 10 plus 3 over 5, or normally we write it 10 and 3 fifths, okay? So that's what actually divided, that's the clean division, and then the 3 is the remainder. The same thing will happen here, okay? Now, how do I know what's in here? And the answer is, I just want to make sure you can see what I've written there. Ooh, just about seeing it. Now you can. The way to find out what this thing is, instead of using long division, is called through inspection. We're going to use a method called inspection. Okay? Now, let's think. I know the degree of this polynomial is 4. The degree of this polynomial is 1. Okay? It's just x, or x squared. Let's start thinking, what will be the degree of this polynomial? What will be the highest exponent of x? Now think about it, okay? If I multiply, let's say it's 7. Let's say it's 7. Just guess. Okay, it's a wrong guess, but let's say. Why can't it be x power 7? Because look, if I'm going to do x power 7, you know how to FOIL, right? Open these brackets. X power 7 times x, that's going to be x to the power of 8. So it can't be x power 7 because there's no x power 8. What about if it's, let's say, x squared? Well, then the highest order will be x squared times x, which is x cubed. But I also have x power 4. Remember, the x that I'm putting here is the highest order. Okay? So I think if you think about it, what will be the exponent on the highest one? It has to be 3. I'm hoping you can see that, okay? Because x cubed times x is going to be x power 4. Now, I got the right order, okay? It has to be x cubed, but I got x power 4, where I have 5x power 4. So again, that's not a problem. We just stick in a 5, right? 5x cubed times x is going to be 5x power 4. And we already got the first term. I'm just checking. I'm just going to quickly write down. I'll just pause this video for a second. Okay, I've just written here, I copied from what we had before, just the result, okay? So that's the result here, and I just want to, as we go along, see that we're getting the same term. Okay, now I got that. Okay, now I might have, let's say, I'll call it ax squared plus bx plus c. Okay, so I'm going to have something with x squared, some with x, and some just a free number, constant. And then I might have a remainder d. So I just need to find, my mission now is to find A, B, C, and D. Okay, let's think about A. That's our next thing, okay? Now, what I'll do it like this. I say, okay, 5 5x cubed times x is going to be 5x squared. That's great. But now let's time by this. So always, just like we did in this one, we timed it by x and then we timed it by minus 2. If I time the 5x cubed by minus 2, I'm going to get minus 10x cubed. Now that's good that I've got x cubed because I've got x cubed here. But I have here minus 13, and here, if I just use that, okay, with this term, multiplying that by that, I'm going to get minus 10x cubed. I need another minus 3x cubed, right? I need to create another minus 3x cubed. I need another minus 3x cubed somehow to turn that into minus 13. Right now, just with this term, okay, and that, I have minus 10x cubed. So I need another minus 3x cubed. Where can I get that minus 3x cubed? Well, I'm not going to get it from here, because that time that would be x power 4. But I'm going to get it from there. If I time this, the x squared, times the x, that's going to be x cubed, isn't it? And how much do I need? I need minus 3. So now I know what the a is. The a is going to be minus 3. See, minus 3x squared times x is going to be exactly my minus 3x cubed. And if I combine those two, I will get minus 3x cubed. And if I combine those two, I'm going to get minus 10x squared. And those together will give you that. Okay, so you see, one by one, we're getting all these coefficients. These called coefficients. So now I'm looking at that. Okay, I'm just going to erase that. Okay, I don't know if you want to copy it. I'm just going to erase it because I think if there's too many things at the same time, it's just confusing. So now I'm looking, I've sorted that. I've got the x power 4, I've got this x cubed. Now I need to make sure the x squares are right. Where do I get x squares? Well, the first x square I'm getting is from that. Okay? So I've got minus 2 times minus 3x squared. That's going to give me 6x squared. Okay, but I don't want 6x squared. I want minus 4x squared. So I really want another term somehow, which will be minus 10x squared, right? Okay, 6x squared minus 10x squared, that will be minus 4x squared. So I need to look around, where would I get that other x squared? That was 1x squared that I got, but the next combination is going to be those two, right? X times bx, that should be equal to minus 10x squared. So that tells you that b is going to be minus 10x, right? Let's check that. Minus 10x times x is minus 10x squared. Those two together will give us that minus 4x squared. We sorted for that one, okay? Okay, it's all falling into place. Let's just check, by the way, in the meantime. Okay, these are the first three terms. 5x cubed, minus 3x squared, minus 10x squared, minus 10x. You can see we've got it's the same one. Okay, we're on the right track. Right, so now we need to look for x. Okay, this is why they wrote for you 0x. Now here I didn't write the 0x. You see that there was, like here, in your exercise, they actually made it easier for you by writing 0x. But, you know, okay, but there is no x. But hang on, I've got, as it stands now, we have an x. Look at this. Those two terms, the minus 10x times minus 2, that gives us 20x. But I don't want to have any x's. I've got 0 x's. So I need to also have another term that will give us minus 20x. And that other term will come from that and that. Okay, I'm going to go around above, if you don't mind. X times c must be minus 20x. In other words, c must be minus 20, right? Minus 20 times x will give us minus 20x. And then it goes, killed itself, 0x like we wanted. Okay? So at this point, okay, it looked like everything is great. Everything is sorted, right? Okay? We've got that, we've got that, we've got that, we've got 0 x's, okay? We've got 0 x's, but hang on, we still need a 6. We need a 6. How do I make a 6? Well, the only way for us to make a number is just one option. You know, when I multiply that by that, that by that, the only way to make a pure number with no x's is 2 times, or minus 2 times minus 20, and that's plus 40. That's the only way. There's no other ways. If I'm multiplying this 20 by anything else, by x, or I'm always going to get something with x, but I want a pure number. But I've got 40 and I want 6. So I need to somehow minus 36. But there's no way for me to do it here. I'm done. I'm finished. I ended up my polynomial. So where's that minus 36 come from? Yes. That's the remainder. That's exactly the remainder. So what I need to do here is to say minus 36. That needs to be on the outer side of the brackets. Okay? That's my remainder. That's my remainder. Okay? Alright? So if I write it again, what I've done, remember we started with that, and then I multiply by x minus 2. What I'm going to do now, I'm going to take this equation and divide both sides by x minus 2. I'm going to divide it. So I'm going to write 5x power 4 minus 13x cubed minus 4x squared plus 6. If I divide it now by x minus 2, what I will get, well, if I divide that side by x minus 2, that's going to cross cancel. So I'm going to get 5x cubed minus 3x squared minus 10x minus 20. But I also have to divide the minus 36 by x minus 2. So it's going to be minus 36 divided by x plus 2. Okay? So if I divide that polynomial by x minus 2, I'm going to get that clean division, just like I had 53 divided by 5, I had that 10, plus the remainder minus 36 divided by x plus 2, which was in this case 5. Hopefully that helped. Let me know if you need anything more. About the last question you asked me, I'm not sure if it's factorization or simplification, so just tell me what's the instruction exactly was. It looks more like simplifying the factorization.